List of things here that I said that you should be able to do. I'm going to do some examples from this list. If anybody has turned in a half sheet, wants it back to perhaps update their half sheet based on what we're doing off this list, you're welcome to do that. Or if you haven't done a half sheet yet and you want to put some of this stuff, want to start making a half sheet now as we're going through the review stuff, that might be a great thing to do also.
Thank you.
Thank you.
You're welcome.
Oh my god.
Oh.
I had a bagel.
I think yours I already stapled on.
I've had one for I think 4 mornings. Thanks.
You're welcome. And Hannah, right here. Nora, do you want your half sheet back to make any adjustments to, or no? If you decide you want it, it's right here. You never gave it to me, but you did email me, which was fine. So you still have it in your possession. Somewhere. You might need to sit down to go through it, though, go through your backpack, which is a bummer. Okay, everybody cool with the plan for today?
Yep. Are we working on
This ended up being like 45-ish minutes when I did it before.
Whoa.
There it is. Got it. So we'll see. But that was what we did all we did on Friday for our second hour. I don't think that's plugged into anything right now, Nora.
My dad
Okay.
wanted to. I asked him to find my thing for the business plan, and he wants to do like this with the plastic and the back.
All right.
And then he's like, I want to make it snazzy.
First bullet point. Write the domain of a rational function using interval notation. So here is a rational function. What do I need to do to write the domain for this? First thing I need to do. Or to write a domain, what do I need to do?
Write a function.
I'll find the zeros. The vertical axis.
So let's back up a step then, because we shouted a lot of things that we do need to do this chapter, but not quite what we need to do for this question. So let's just back out just a minute. What is a domain for any function? It's the set of x values that
Equals 0. No.
that pair to a y value. No, it's fine. I love that you're trying to participate. Keep trying to participate. It's okay. That's the way I learned too, right? Like I got to get all the wrong answers out of the way before the right answers stick in there. Get all the wrong ones out. Get them out now, right? Before the test day.
Or the test, yeah.
Vomit out all those wrong answers so the only things left are the good ones. So the domain is just the set of x's that pair to a y. So what we need to worry about in a rational function is the operation of division. Because when does division fail to produce an answer? When we divide by 0. So that is what I'm going to be concerned about when I'm writing a domain for a rational function, is where am I, what x's are going to cause me to divide by 0. So what part of this function is the divide by part? The numerator or the denominator? Denominator. So I'm just going to set the denominator equal to 0. Everybody good? How do I solve x squared minus 4 equal to 0? So you could do this two ways. You could solve the quadratic directly, since there's only one kind of x in x squared. Or you could factor. I like the factoring route, but it's not wrong to do it the other way. The catch with the other way, though, is you have to remember the plus or minus when you squirt both sides, and that's an easy thing to forget. If you factor, you can't forget it. So let's factor. How does x squared minus 4 factor? Great. So when we set each piece equal to 0, we get two solutions, 2 and negative 2, correct? Now, these are the values that make the denominator 0, correct? These are the values that I don't want in my domain. How am I going to write my domain using an interval notation so it represents all the x's except for negative 2 and positive 2? AJ.
Is it like negative 2 and then like greater than, or is it the one where you have like the 3, you do like negative 2 and then the one like it's like a greater than or less than?
We're not going to do greater thans and less thans with interval notation. That's the one with the parentheses and the brackets. But you could write a domain with greater thans and less thans. That's okay, but not the directions here if we're asking for an interval notation. Which one should come first, negative 2 or positive 2? Negative 2 because it's smaller, right? The smaller number should be the first thing, okay? And why am I using a parenthesis there rather than a bracket on the negative 2? What is the difference between parentheses and brackets in interval notation? A bracket would mean that number is included in the domain. A parenthesis would mean it's not included in the domain. Why don't I want to include negative 2? Why am I?
It's included.
Why do I not want to include negative 2? What does negative 2 do to this function? It makes
0.
the denominator 0. So I don't want it, right? Okay, so that's one part of my domain. What else do I have? Okay, we always go write our intervals from small to big. Is positive infinity bigger than 2 or smaller than 2?
Oh, so it'd be 2.
Okay, 2 positive infinity, but you missed one.
Negative 2.
There you go. Thanks, Reagan. We also need the numbers between negative 2 and positive 2. So if we think about this, we have everything, right? The stuff that's less than negative 2 is here. The stuff in between negative 2 and 2 is there. And the stuff bigger than 2 is there. So we have everything except for those two numbers. Questions on how to do this? In general, what are the steps? Set the denominator equal to 0, solve, and then write your interval for everything except for those solutions.
So you just have to do the denominator?
Just have to do the denominator for a domain. That's all we care about. Because in division, that's the only situation that can give us no answer, is if we divide by 0. If we take 0 and divide it by something, that's just 0 unless we're dividing by 0. All right. What if I want the vertical asymptotes? What do I do for this? What? Set what equal to 0 again? Close. You were closer before. You have to do something before.
Factor, then set it equal to 0.
So the reduced denominator set equal to 0. So to reduce this, we need to factor. So let's factor the numerator. How does the numerator factor? Who can factor x squared minus 5x plus 6?
Negative 5. Negative. Wait,
I'll give you a clue. Multiplies to give you positive 6, adds to give you negative 5.
X minus 2 and x plus 3.
Nope. Minus 3. Because negative 2 plus positive 3 give you positive 1. and they multiplied to give you -6. You had the signs swapped, I think. Everybody's okay there? We good with factoring? You can remember how to do this. It's like an Algebra 1 skill. Should reinforce in Algebra 2. Should be the one thing you walk out Algebra 2 feeling confident about doing is factoring trinomials with leading coefficient 1. What do you notice when you factored this? The x minus 2s, what can we do with them? Bye-bye. So my vertical asymptote then, I'm going to set just the x plus 2 equal to 0 and solve. Done. Everybody's okay? What's the other type of discontinuity I can get other than a vertical asymptote? And that's not a discontinuity. A removable discontinuity. Where do the removable discontinuities come from? Anything that I completely reduce from the denominator. So notice there's no more x minus 2s after I finish reducing. That's going to generate a removable discontinuity. But a removable discontinuity isn't a line like a vertical asymptote is a line. A removable discontinuity is a point. It's a single location. So this x needs a y value attached to it. How do I find the y value to go with the x equals 2? I plug it into the reduced function. Right? That reduced function is y equals, since I've crossed off the x minus 2 term, I've effectively removed the discontinuity of 2, so I can find where that point would have been. What do you guys think?
What's like the question on the test?
Find the removable discontinuity for y equals yada, 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 yada.
So why did we have to find the VA?
Because it was like, because they're like kind of co-problems. But it could just be like one, Cash could do one or the other. I just found both of them because we've been doing the same problem for, you know. Maybe I should say this is, let's just change that to just discontinuities. So there's me doing a VA and an RD for this, using the same function. Is that okay? So that's covered the first 3 bullet points, I think, right? Questions so far? Doing okay? You'll stop me if you're unsure, right? Okay, what if we have the same function and we're looking for the zeros? How do I find the zeros for a rational function? Close. Reduced numerator set equal to 0. So again, yes, we have to factor it first. See if there's any reducing. We know there is because we did this problem earlier. So I'm just going to take that reduced numerator, set equal to 0, and I'm done. Yep. So again, so quick little review here to summarize. Domain, denominator set equal to 0. It's been the same function the whole time. That's okay. Vertical asymptote, reduced denominator set equal to 0. Removable discontinuity, the things reduced from the denominator, the stuff you crossed out, set equal to 0. Zeros, reduced numerator set equal to 0. Which I know is kind of confusing. I'd probably want to write that set of 4 things down on my sheet so I remembered, like, what am I setting equal to 0? Because it feels like I'm just going to grab bag pick 'em. Right? So make sure that you're clear on that. If you're not sure, or if you think you might forget, like, write that stuff down. That's why we get a half sheet, right? Okay. Y-intercept. How do I find the y-intercept? What is a y-intercept? Graphically, what is that? What is a y-intercept? It's where it crosses the y-axis, right? What is the x-coordinate for any point on the y-axis? 0. Guess what I'm going to do to find the y-intercept? Plug 0 in for x. Exactly right. Very good. Boom. Done. Right? Nothing to it. It's all right. I think this example I gave you is fairly representative. Now think back to the homework quiz that you guys took the other day. What happens if, say, like, one of the numerator denominator is not let's say if the numerator is not factorable and you have a problem like, like this one we're asking about vertical asymptotes. If I can't factor the numerator, can I reduce it? Will I be able to reduce the fraction if I can't factor the numerator? No. Right? If the numerator isn't factorable, how can I reduce it if it has to be in factors to cross out, right? So if you can't factor the numerator, that's good news. Just means that, okay, I have to set the denominator equal to 0. There can't be any removable discontinuities. Nothing weird's going to happen. Just go about my business. Yes, Nora.
Can I use the bathroom?
Sure. All right. So the next question here, it says, write the end behavior for the function using limit notations or proper limit notation. So let's say for a problem like this, I'd give you a picture like this and ask you to write the end behaviors using limit notation. How many end behaviors should you have to write for this problem that you're looking at right here? Nope. 6. Where are the 6 of them?
Oh, each of them.
1 for each arrow on the graph. Everybody okay? So this would have 6 end behaviors. So every limit notation is going to look like this. We just have to fill in the value for x and then fill in the value that it's equal to. Right? We have to say, write down what x is approaching and then what the y is approaching. So this is like, everybody's okay? So let's look at that arrow for A. What x value is that arrow pointing at? Negative infinity. So that's what I'm going to put down at the bottom. And what y value is that arrow approaching at, or pointing at? Isn't it pointing along this one? That y value? At -2. Because the graph is horizontal there at -2. You guys see that? The arrow's like flat, like horizontal. Let's look at B. So I always start just by writing that part. Let's look at that arrow at B. What x value is that arrow pointing at? It looks like it's pointing at this vertical spot right here, right? The arrow's vertical. So it should be -3. Everybody good with that? But there's a little bit of an issue here. What is the issue with this? How many arrows are pointing at -3? 2. We have to differentiate between them. The one that we're talking about, the arrow that I've circled and labeled as B, is on the left side. To indicate that I'm talking about the arrow on the left side of -3, I'm going to put a minus sign in the superscript of -3, meaning that it's on the negative side of -3, where the smaller numbers, the -3, live. Everybody's okay with that? Now, if I look at the arrow at B and I look at the y, what y value is that arrow pointing at? It's pointing straight up. What y value is straight up? Positive infinity. Let's look at arrow I've labeled C. What x value is C pointing at? Again, it's at -3. But which side of -3 are we on? The negative side or the positive side of it? The positive side of it. So we're going to use a positive superscript there. And what y value is C pointing at? Positive infinity, because it's pointing straight up. Everybody's okay with that? Arrows pointing straight up are the y is positive infinity, straight down they'd be negative infinity. If they're horizontal, if the arrow is horizontal, then it's going to be whatever that y value is at. You have to trace over and kind of look. All right, D. What x value is D pointing at? 1. Which side of 1? The left side or the right side? The left side. So how do I indicate the left side? A negative in the superscript, right? Very good. And now which y value is that arrow pointing to? Negative infinity because it's straight down. Is it starting to feel okay? I picked one with a lot of parts to it so that we had to got a lot of reinforcement here. I don't think there's 6 parts on the test. Okay. E. What is the x value that E is pointing at? 1. Which side of 1, though? The positive side of 1. Very good. And what y value is E pointing at? Negative infinity. Good. Last one. Okay. What x is the arrow at F pointing towards? It's not -2. -2 is a y coordinate. See how it says y equals -2? Right? We're asking for what x coordinate? Positive infinity. Very good, because that arrow's pointing to the right. That's where the positive infinities live on the x-axis. X is left and right. What is the y value that F is pointing to? Now it's time for the -2. Very good.
Under E, it's like X.
1 plus. The plus sign's in the superscript or whatever. Does that feel okay? You'll have to do something similar to this on the test, right? So, again, make sure you're familiar with the notation. That's usually the hardest part. If we look at our eyeballs, we can usually see what's going on, but getting the limit notation straightened out is sometimes tricky. All right. So just like on the homework quiz, I'm going to give you a question where I give you some descriptions about what your graph should look like. And then your job is to draw the graph. Make sure that those are all updated. So I'll give you a second if you're writing down this as an example to write this down, and then we'll start talking through how to do something like this, or what's the easiest way to do something like this. Yeah. Absolutely. No problem. All right. So what's the first thing that I want to start drawing when I draw my picture? First thing I want to draw are the asymptotes. So far, so good. The next thing I'm going to do is draw my zeros. The third thing I'm going to do is draw in my removal discontinuity or my y-intercept if I have them. Now, when I draw my removal discontinuity, how do I draw that? So your zeros and your y-intercepts are going to be closed circles, closed dots. Your removable discontinuity is going to be an open dot. Is everybody okay with how I did that? Now, the first part that I'm going to do now with the end behaviors is I want to do this part of my graph. So I want to look at what's happening on the positive side of -2 and then the negative side of +2. So the positive side of -2, it says the end behavior is pointing down. And then the negative side of +2 says the end behavior is pointing up. Everybody's okay with how I read that? So I know my graph has to connect those, and it's okay that I cross a horizontal asymptote if it's in the middle. That's okay. Never can you cross a vertical asymptote, and you can't cross your horizontal asymptotes on the ends. But in the middle, it's okay to cross. Is everybody okay with how I drew that part of the picture? Okay. The next thing I want is to draw what's happening over here. So that's going to be the left side of -2. Well, that my end behavior says it's pointing down. Should be an equal sign there. And I know that that's got to go through the 0. And then I shouldn't cross the horizontal asymptote at the end, so I know it's got to be doing that. And notice that this piece matches what I'm seeing there, that as we're going to -infinity, we're sticking right along y = 3. And then the last piece I'm going to do is this side of my asymptote. That corresponds to the right side of +2, which says is +infinity. And that's got to then just follow the horizontal asymptote. And notice that that piece matches exactly what I'm seeing there. That as x goes to +infinity, y is at 3. So that's what I'm seeing there. Notice what pieces of the end behavior don't I really look at? The pieces where x is going to infinity or -infinity, right? The reason I don't do that is because those are really the same thing as my horizontal asymptote. By drawing in the horizontal asymptote, I've already kind of done that already. So I don't really need to consider those when I'm drawing my picture. That feel okay as to how to kind of chunk that kind of a problem out to make it doable? At minimum, everybody should be able to do these parts pretty easily, right? That's a bunch of points on your test to just fill that stuff in correctly, even if you goof up the end behaviors. Is that okay? Questions on what we did here? Okay, did it help? Like, talking through the order in which to deal with these things is probably helpful. Okay. All right. Let's take a look now at solving. So this is an equation. How can I tell it's an equation rather than an inequality? There's an equal sign in it. Very good. All right, step one to solving a rational equation should be to do you see any like terms to combine? I don't, because there aren't any. And typically there wouldn't be, although that's a reasonable thing to look for. Because if you see that and you can do it, certainly that makes your life easier. But there aren't any here.
I don't know how.
Okay.
Can you like unfactor that?
You mean factor that?
Yeah.
Yes, that is the first step, is what you'd want to do is start by factoring. So the only thing that can factor are the denominators, correct? If you look at the numerators, x isn't factorable, x plus 2 isn't factorable, and 1 isn't factorable. But x squared minus 1, how does that factor? Who can tell me? X squared minus 1, how do I factor that? This should be an easy one to factor. X squared minus 1. Does it help if I point out to you that 1 squared is 1? Well, that's a difference of 2 squares then, right? So it should be x plus 1, x minus 1. Who can tell me how x squared plus 2x plus 1 factors? Guys, what multiplies to give you 1 and adds to give you 2? 1 times 1. Now, I have x plus 1 times x plus 1. That's fine way to write it as a factored form. Though the way I want to think about it, or that I'm going to think about it,
What time do we end? Is it like normal?
it's like a 65-minute class. Let's just focus on finishing up. Okay. Everybody's okay with what I've done so far? My goal when solving, now that I have it in a factored form, is I want to multiply both sides of this equation by something to clear the denominators out of there. So my goal, I want to multiply both sides of this equation by something so that when I'm done, no more denominators. What does that something have to be in this case? It has to be the least common multiple of the denominators. So how many distinct factors do you see in our denominators? I see 2. I see x plus 1s, and I see x minus 1s. Everybody agree? Now, what is the biggest number of x plus 1s in any denominator? Two, because that middle denominator is x plus 1 squared. There's 2 copies of it in that denominator. What's the biggest number of x minus 1s in any denominator? 1. The first denominator is the only place x minus 1 occurs. Everybody's okay with how I got the least common multiple. Now that's going to distribute. And I guess I need to do that to both sides. When I multiply x plus 1 squared times x minus 1 to that first fraction, notice that the x plus 1 cancels out and the x minus 1 cancels out. And we're left with x times x plus 1. Can you see that? Oops. When I multiply it to the second fraction, the x plus 1 squared cancels out. So we're left with the x plus 2 and then the x minus 1. And when I multiply over on the right-hand side, one of the x plus 1s cancel. So I have 1 times x plus 1 times x minus 1. Is everybody okay with what we've done so far? Notice that no denominators are left. Yay! What should I do now? I'm going to multiply things out. So I distribute the x through on the first term. I'm going to FOIL out the second term. And then FOIL out the right-hand side. What type of equation do I have left here? Well, it's a polynomial because it's all just like multiplication, addition, subtraction of x's and numbers, right? Everybody agree? And the biggest power of x is 2. So what type of polynomial is this? Quadratic. How do I solve a quadratic equation? Or factoring. To do either one, what do I have to do first? It's got to equal 0. So everything's got to get onto one side, and we got to combine some like terms. So I'll start by subtracting x squared from both sides. So those x squareds just can kind of cancel out. And then I'll add a 1 over. So I have x squared plus 2x minus 1 equal to 0. Ooh, do you guys see two numbers that multiply to give us -1 and add to give us +2? I don't. What that means is that this is not going to be factorable. But that's not a problem, because what can we still use? Quadratic formula. So x equals -b plus or minus square root b squared minus 4ac all over 2a. Two squared is 4. 4 times 1 times -1 is 4. 4 plus 4 is 8. I'll reduce the radical of square root 8. I know 8 is 4 times 2. So the square root of 8 is square root of 4 times the square root of 2. And square root of 4 is just 2. And then I can reduce that way. So I have -1 plus or minus root 2. Before I'm done, what do I have to remember to do? Check for extraneous solutions. I need to check to see if this denominator or this solution makes a 0 in my denominators here. Well, it doesn't, right? The only thing that's going to give me a 0 in the denominator is either 1 or -1. And that ain't what I got. So that's my answer. Does that feel okay? Last example. Inequality. To solve a rational inequality, I'm interested in two things. My discontinuities and my zeros. Oh, before I do this, I guess I'm going to pretend that's an equation, right? Should say that. Okay. How do I find my discontinuities? We just did this earlier. We set the denominators equal to 0, right? Because it's discontinuity, so it doesn't matter if it's removable or if it's an asymptote. I don't care. I just need to know what those discontinuities are. I don't need to know the type, so I'm not going to be picky about it. I'm just going to take the denominator, set them equal to 0. Everybody good? How do I find the zeros then? Well, it's not a single fraction, right? The zeros are just going to be the solution to that equation. It just turns into a solving equation, right? Now, Avery, I could make a common denominator, add these two fractions together so that it's a single thing, and then I could set the numerator equal to 0. I would not do it that way because that's a lot more work than what we're about to do to solve it. But you could do that. So your answer's not technically wrong. It just, I would advise against trying to do it that way. So notice that there's nothing to factor in these denominators, right? So what do I need to multiply both sides of this equation by to clear the fractions, to get rid of the denominators? Should be real easy. What's the least common multiple of x minus 3 and x plus 3? That'd be the greatest common divisor. It's going to be x minus 3 times x plus 3.
I knew that.
Me too.
So the x's throw you. If I asked you just for the least common multiple of 3 and 4, hopefully everybody would say 12. Or I should say 6, right? 6 is the least. Yeah. No, 12 is right. Anyways.
Because if you're, you got one.
I'm just trying
Just ask her.
Is everybody okay with how I did the finish solving that? I'm not done though. Now that I've drawn my, or found my discontinuities and my zeros, I need to draw a sign diagram. So I start with my smallest value, next smallest value, biggest value. The discontinuities always get open circles. The zeros depend on whether it's a strict inequality or if it's an or equal to inequality. Since I have an or equal to inequality, that should be filled. And now I'm just going to pick some test values. And plug in to see if I'm going to get positive or negative results. Now, my suggestion to you on a problem like this that's like kind of difficult to plug in, you're going to have to like deal with some fractions and stuff. I don't want to have to deal with that. So I'm going to just do this all in my calculator. So the easiest way to do that is to just plug in the function into y1. So I'll do 2 over x minus 3. And then minus 4 over x plus 3. And I'll exit out of there. And then I'm going to use that y1 command. So I'll do vars, yvars, function y1. And I'll do that of negative 4. I get a positive. I do that for 0. I get a negative. I do that for positive 4. I get a positive. And then I do that for 10, and I get a negative. So because it's a less than or equal to, I want those two parts. So my solution is negative 3 to 3, and then 9 to positive infinity. Notice that I used the bracket for 9. Why did I use a bracket on the 9 but nowhere else? Because it was the filled in circle. Excellent, Lexi. Okay, that's it for today.
Yay, can you scroll?
The second to last one. Yeah.
It's all in the OneNote also, you know. Oh, you're trying to do your half sheet. I understand. Start a new pile there. So again,